My dear students, welcome to EPG Pathsala. My name is Dr. H13CT18. I am working as an assistant professor at Tamil Nadu Agriculture University. Today we are going to see about remote sensing technology. You know, the term seems to be very fancy, but it's a very simple term. Let me start with an example of giving our own human race as an example. Okay, so we do have got sense organs, right? So we have taste buds, skin, and we have eyes, nose and ears, which senses different organs that we see every day, that we see, taste, smell, or whatever it may be. Okay, similarly, there are certain tools which are used to detect objects that are far away from the reach of us. So those tools are called as remote sensing tools. So in the other way, it can be said as objects that can be viewed or that can be easily measured with the help of a tool which cannot be having a direct contact with the human body. So that is what is called as remote sensing tool. So with this small introduction, let us get into the topic. So there's nothing to feel more odd about what is remote sensing and or how it could be learnt, but it is very easy. Like as I already said, remote sensing is nothing but sensing the objects that are far away from the reach of our senses. Okay, so we do have a lot of celestial bodies in our space and a lot of galaxies like our own. So how these galaxies are identified or how these stars are identified? Is it through satellites, right? So NASA has developed a lot of satellites in order to capture the images of the celestial bodies that are present in and around the space. We cannot see it through the direct eyes, right? We can see it only through the images that are being produced from NASA and if it is being published in the newspapers. So it's a kind of a tool. Remote sensing technology can be done only with the help of certain tools that can able to capture the image or identify the characteristics of object without having any direct contact over it. So let us see what are all the elements that are associated with the remote sensing technology. Okay, so there are totally 7 elements starting from the energy source. We all know that our prime energy source is the sun. So only through sun we could able to get energy, or only when the rays falls down to the earth, the objects present on the earth could emit certain radiation through which it could be identified. So we have 7 classifications of elements that are being involved in remote sensing process. Number 1 is the energy source. Energy source is the sun, in fact. What is the second one? It is the radiation and the atmosphere. What is radiation? The energy of the sun could penetrate only through the atmosphere, and once if it penetrates, it has to hit an object which is present on earth. So once if it hit the object, every single and tiny object in the earth has a reflection property. Some will naturally reflect or some will be induced to reflect. Okay, so for the natural reflection, it is called as the passive reflection, or if it is induced through certain tools like radar or X-rays, for example, those are called as active remote sensing. Okay, so the radiation and the atmosphere, like I already said, once the sun rays falls down to the earth through the atmosphere, it will hit the object, and the object, in fact, it starts reacting to it. So that reaction is called as the radiation. Then the interaction with the target. Once if the target is being interacted, it radiates and the electromagnetic waves starts reflecting from the object. And these reflections are being recorded by the sensors which are present in the remote sensing tool. Say for example, if a satellite is capturing the downfall of the river from the atmosphere. So once if the radiation hits the atmosphere, the rays comes down to the place of the river, and from the river the radiation again reflects back in the form of electromagnetic signals, and those electromagnetic signals are being captured through the sensors of the satellites. And these sensor, what it actually does, it transmits all the signals that are being received to the station below, and those stations are the operating agents. So they operate whatever the signals that are being received, and they will again process it, and this processing will be carried out in the type of images, and these images are used for interpretation and analysis. Interpretation, what does interpretation means? Interpretation is nothing but how these signals are received and in what way these signals are processed and how it is used. Say for example, for me, I have to study the Kaveri river. So where it originates and where it ends. So I need to go through all the directions of the river, and it could be possible only with a remote sensing tool. So what I do, I go for the Kaveri river's origination place. So in that origination place, I will be seeing exactly the latitude and longitude of origination, and from there again I have to pass through the way where the river passes and finally where it ends. So when it ends to that particular point, I have to see what is the latitude and the longitude. So that part is called as an interpretation, and that analysis part is being carried out, and then it is being applied for the further studies. So if I have to see the origination and the end of the Kaveri river, I have to interpret the data that are available through the satellite images, and then I have to analyze it from where it starts and where it ends, and then I have to apply it for the study and for what purpose I am doing it for. So these are the elements of the remote sensing. There are totally 7 elements again, I should say. The first one is energy sources, the second one is radiation and the atmosphere, the third one is interaction with the target, the fourth one is recording the energy by the sensor, the fifth one is transmission, reception and processing, the sixth one is interpretation and analysis, and the seventh one is how to apply, that is application. Let us see what are all the types of remote sensing. There are two main types of remote sensing. One is passive and the other one is active. Passive remote sensing, like I already said, there are certain objects in the earth which can emit its own radiation naturally. So when these object emits their radiation naturally and it being captured by the sensor, those sensing is called as the passive remote sensing. What is active remote sensing? See, right, I am facing the camera right now. So, and the camera could able to capture me, and you could able to see only my physical structure, but you cannot able to see my skeletal structure which is present inside. So my physical body radiates the passive remote sensing type, but if you have to see the skeletal or if you have to study my skeletal organ, then you have to use certain tool called X-ray. So X-ray can only penetrate through our body, and it can give you a clear picture of how my skeletal system is. So if you could able to take other example, radar could be one of the best example I could say for the active remote sensing, because radar is the only tool that could able to constantly monitor what is happening in the atmosphere. Especially lot of aircrafts are being flying around the country, around the world in fact. So how these aircrafts are being monitored? It can be monitored only through the help of radar technology. Okay, these radar technologies are nothing but the transmitter antenna type, and these transmitter antenna, what it does, it directly penetrate to the object and it will identify where exactly that aircraft is moving at right now. So radar is one of the best example for active remote sensing, and the electromagnetic radiation that is being produced from the radar, it will hit the object that are present in the atmosphere, or hit the object of the aircraft, and through this the aircraft starts reflecting that particular thing which is emitted artificially. Those artificial emission of radiation is called as active remote sensing. Okay, we have been seeing through the elements as well as the types. So what we are going to see right now? Okay, these elements, these types, okay, all these are all the availabilities of remote sensing tools. What it actually does, it takes or it collects data. It takes information from that object, or it collects information, or it gathers the data from the object. Okay, there are two different kinds of data collection by a remote sensing tool. One is multi-stage remote sensing, and the other one is stereo pair remote sensing. Okay, what is multi-stage remote sensing? At different stages, the images are being captured based on the reflection it gives. Okay, so you have three different classification in the data collection in the multi-stage remote sensing. The first one is satellite based remote sensing. The second one is aerial surveying remote sensing, and the third one is ground based remote sensing. Let us go to the satellite based remote sensing. Satellite based remote sensing often helps in establishing a stable platform by obtaining more accurate data with less geometric error. Fixed spatial resolutions and more time consumption are some of the disadvantages in this method. satellite based communication, as the definition would say, that you can able to get up or obtain data that are so accurate and which does not have any geometrical errors. So these geometrical errors are one of the main criteria that we need to take care of, because if we are focusing or we are capturing the image of the object which is present down the earth by a tool which is present above the earth, when that image is being captured, so it has to produce it at what latitude and at what longitude these images are being captured. Only then it could able to give a clear geometric error address or clear geometric data. So satellite based remote sensing is one of the multi-stage remote sensing data collection which is used for obtaining the data of different aerial views of different plantations, or you can able to identify the reservoirs, or you can able to identify what are all the places that are present above the mean sea level, that are present below the mean sea level, etc. Coming to the aerial surveying. Aerial surveying has high geometric errors because these are being surveyed only with the help of the aircrafts. And today now they are using drones. Today the technology is like using drone. They could able to capture the pictures. It is called the bird's eye view. I could able to say aerial surveying is a kind of a bird's eye view which could able to give you a clear picture of what is exactly present down the earth. But it cannot give the geometric values of exactly which latitude and longitude it is present. So it needs some sophisticated geometric correction models in order to give you such a concrete result. This aerial surveying can be used only for specific purpose, and it involves a high cost, and it is differentiated from the satellite based remote sensing by variable spatial resolutions and non-constraints of time. Then coming to the ground based remote sensing. So these remote sensing tools are used for studying the blind spots on earth, soil compositions, traces of water bodies, etc. And these are all one of the prime tools used for scientific experiments. Very recently they have said that there are traces of a river that are being run beneath the sea, beneath the ocean. They have recently identified it in Brazil. So these kind of technology, how it could be possible? It is possible only through the ground based remote sensing tools. Then the next one is the stereo pair remote sensing. Stereo pair remote sensing is done with two images of the same area are acquired on different days and from different orbits. One takes from the east and the other is taken from the west. Usually these images are captured based on the sunrise and sunset. The sun rises in the east and ends in the west, right? So because only, as I already said, the sun is the only prime source which could able to produce the radiation, and which could allow the object to emit its radiation. The image is also captured only in this phase from east to west, because once when the sun rises, the object on the earth will start reflecting. That is why we call daylight and we call night. Day and night is only because of the reflection of our own objects on earth and not because of any other thing. So these reflections are being captured through the stereotype remote sensing tools, and this stereotype remote sensing captures the photography based on the radiation, uses it in the image form, and that image is called as the digital evaluation model, and it uses the photogrammetric technology to generate it. You could see the India map here. In this India map is taken by one of the stereo pair remote sensing tool. The image was taken in such a fashion that used the photogrammetric technology to generate all these parts, and it has been converted into the digital elevation model in order to give you a concrete result of what is actually present in the world. Coming to the resolutions, okay, everywhere there is a resolution problem. Even in the cameras nowadays, the 2 megapixel camera could give you a moderate picture, but a camera with a 12 megapixel will give you more concrete or more clarity in the photo. Likewise, this is all happening because of the resolution. A 2 megapixel camera will have a small resolution than the 12 megapixel camera. So the resolution here can be of various ways. One is the spatial resolution. Spatial resolution is, it provides visible image by detecting even the smallest possible objects on earth. For example, capturing an aircraft or an airport through aerial mode. So through space, when this is being captured, we could in the picture you can also see the flights that are being the flights that are standing in the airport. This is called as the spatial resolution. This image that gives you exactly what is present in that airport. You can even the aeroplanes are also being spotted in that. So it provides visible image by detecting even the smallest possible object on Earth. The next one is spectral resolution. Spectral resolution discriminates the wavelength interval in an electromagnetic spectrum. Here the low resolution yields wide bandwidth and the high resolution yields small bandwidth. In the picture you could see the vegetation spectrum in detail. All these images are being taken through spectral resolutions. The resolution low concentration gives you a wide bandwidth and the high resolution here gives you small bandwidths. Temporal resolution. Temporal resolution is the time taken by a satellite sensor to complete one single rotation around the Earth's surface. Unlike other satellites, for example geostationary satellites, it revolves in the same direction as the Earth spins. The satellite sensors having the temporal resolution will have sufficient time between each rotations. If you take the example of Landsat or RadarSat-1, the time taken between one single rotation to the other single rotation, or the image captured at one point of the same spot and the other point of the same spot, will be different. The Landsat satellite, for example, it takes like 16 days for its next visit to the same spot, whereas the RadarSat-1 takes 24 days between each rotations. Then radiometric resolution. It captures the image that emits bright light. This can be perceived based on the reflection of the energy emitted from the object that is captured. Higher the resolution, better will be the reflection. So these kind of cameras we use for obtaining the radiometric resolution should have more resolution powers. Only then it could able to emit the radiation and could capture a better object. Okay, so the process is not over if we don't read the history, because history is the backbone of everything. History of the remote sensing, how this technology was developed. It all started in 1839. It is the beginning of the practice of photography. And in 1859, a person called Gaspard Tournacon, he used a parachute to capture the first aerial photograph of a small hamlet in Paris. In 1873, the theory of electromagnetic spectrum was proposed by the James Clerk Maxwell, and even today, his theory stands to be the best theory for electromagnetic spectrum. In 1909, the images from aircraft created a revolution, and in fact, it popularized the term called bird's eye view. It was showing much more objects on the Earth from the aerial point of view. And in 1935, the first transmitter antenna I told you before, which is now called as a radar, was developed with experiments by Heinrich Hertz. In 1939, the term radar was officially named by the US Signal Corps, and in 1959, the first space photography of Earth was captured by the Explorer 6, an American satellite. These are some of the other discoveries in the remote sensing technology. In 1960, the revolution of TV that came into existence. Now there are a lot of technology that are being used by the television companies, manufacturing companies. So it all started in 1960s only. So 1960, the United States first launched television infrared observation satellites. And in 1970, Skylab space station called Salyut was first launched by the Soviet Union. Then in 1972, Landsat-1, an Earth Resource Technology satellite, was launched by the United States. 1982, Landsat-4 was launched by New Generation Sensor. And 1986, Satellite Observation de la Terre. It is called SPOT, a French commercial Earth observation satellite that was launched. And in 1990, high-resolution spaceborne system was established. 1998, cheap one-goal satellite mission was taken into consideration, and it was a very successful mission also. In 1999, Earth observing system was launched by NASA, and Iconos satellite was launched with very high spatial resolution sensor systems. These are some of the history of remote sensing technology. Okay, where these technologies are applied? Well, these technologies are applied in all the fields today. For example, agriculture, forestry, geology, urban planning, water and environment. You take agriculture, for example, what specifically this technology is applied, or where specifically this technology is applied. This technology in agriculture is applied for classifying different crops and its types, for observing crop productivity, for assessing periodical soil moisture content, and for notifying the incidence of pest and disease damages on crops. Whereas in forestry, it assesses crop density and estimated yield, assessing the disease and the damage caused due to fire and natural calamities. In geology, it is exploring oil and gas resources, preparing structural modules. It studies the tectonic plates and analyze its hazards, study on natural calamities, floods, storms, etc. Urban planning, demarcation of land through maps, infrastructure plan and sitting studies, changes in the demography and culture, and assessing the mobilization pattern. Water and environment, preparing maps for land types, preparing maps to assess the habitats and the resources, assessing the pollution rates, and study related to hydrology and coastal areas. So these are all the fields in which remote sensing is applied. So having seen all these innovations in this technology, right from parachute aerial photograph to the satellite images, remote sensing is one of the best tools at present for various purposes of studies. In fact, if you take agriculture, it helps for a scientist to know what crop it is or how it can be classified and at what category it could be typed. Or if you take a water reservoir or a source, it is very possible to observe what is actually present there in the earth and what is its composition, its depth, and how it can be measured. So for all and everything, remote sensing technology is the base. This is just a beginning. There are a lot of innovations in the future that are yet to come, which will in fact boost this technology and which will ease the work of the scientist or the other common man, or ease the learning even for you people who could able to analyze using its image for further research or study purpose. Thank you students for watching this video.